Very good morning to everyone present here. It is with immense pleasure and honor that I welcome you all into the inaugural session of the online FTP program on smart building design, ECT for net zero, that is energy efficiency control system and thermal comfort, organized by Electronics and ICT Academy at NIT Patna in association with the Department of Architect and Planning and the Department of Mechanical Engineering, NIT Patna, sponsored by the Ministry of Electronics and Information Technology, Government of India. This faculty program scheduled from 2nd to 11th June 2025 and aims to explore the faculty members, various people, research professionals with an integral understanding of smart building technologies, focusing on the mainly energy efficiency, thermal comfort, and modern control towards the net zero buildings. So we are truly honored to have with us today's Professor Meena from the prestigious institute IIT Roorkee, CBRI, as a guest. And sir, we have deeply grateful for your presence to look forward your insightful words and valuable guidance. And at this moment, I would like to call Head of the Department of Architect and Planning, Dr. Professor Fulena sir, to kindly share his views on this FDP program. Professor Fulena sir.
Thank you, MP Singh. Good morning to all esteemed dignitaries, faculty members, and participants. It gives me immense pleasure to be part of the inaugural session of this online faculty development program on a smart building design (ECT) for net zero energy efficiency control system, thermal comfort. This program organized by the Electronics and ICT Academy, NIT Patna, in association with our Department of Architecture and Planning and Department of Mechanical Engineering, and sponsored by the Ministry of Electronics and Information Technology, Government of India, address topics of urgent relevance in today's built environment. The transition to a smart, sustainable, and energy efficient building is not just a technical necessity but a responsibility we carry as educators and professionals. I believe this faculty development program will provide a valuable platform for knowledge sharing, interdisciplinary collaboration, and innovation. I congratulate the organizing team for curating such a timely and meaningful program, and I extend my best wishes to all of the participants for productive and enlightening experience. Thank you.
Thank you, sir. Now I take the privilege to invite the convener of this FDP program, Dr. Vijay Kumar, Associate Professor, Department of Architect and Planning, to brief outline and objective of our course structure, this FDP program, to the participants and the experts. Sir, please.
You are not audible.
Thank you, Ravi Kumar. And thank you, Head of the Department, Dr. Fulena Rajat sir. Good morning to all the respected dignitaries, the Director of NIT Patna, Dr. P.K. Jain, the course coordinator, myself. Welcome also all the dignitaries, esteemed speakers, and dear participants. It's my privilege to welcome you all on this online faculty development program on smart building design ECT for net zero. So it will cover three aspects of the building. That is the energy efficiency. That means how much energy the building consumes annually per square meter. That is the indicator that we use to measure the energy efficiency of the building. The control systems, that means how do the various controls in mechanical, electrical, electronics, AI, all these factors that affect the control that guides the energy consumption of the building, and also the thermal comfort that we will discuss during the next 10 days. So all these three combinations, that is energy efficiency, control system, and thermal comfort will be the keywords for our FDP program. So this FDP is organized under the aegis of Electronics and ICT Academy, NIT Patna, which is privileged to among the few IITs, NITs, and triple ITs that have got this mission that is by Government of India initiative to train the faculty across the country with some mission for energy conservation, the control system, and also the thermal comfort. The primary objective of this FDP is to provide participants with comprehensive understanding of smart building technologies and their role in achieving net zero energy goals. So the primary goal that we faculty or we the whatever organization we have is to inculcate in our students to develop such buildings that will have a net zero consumption. Net zero doesn't mean that it does not take from the grid, but the energy consumed by building is produced within the buildings. That means it is two-way, means building also produces the energy, it supplies to the grid, and in need of it, it takes from the grid. So the net consumption of a building, that is zero. So our target is to achieve the net zero, and it is feasible at the current stage of development. It is feasible to achieve the net zero building. So over the span of 10 days, the program will feature expert lectures, case studies, interactive sessions, and hands-on demonstrations delivered by leading academicians, researchers, and industry professionals. So we have the scientists from CBRI, we have the faculties from IITs, the NITs, the SPAs. So we have a team of both the researchers, the scientists, and also the academicians, and also the practicing architects who will deliver the hands-on experience and the process how they have achieved the net zero buildings. So this program also encourages cross-disciplinary engagement between architecture, mechanical engineering, electronics, AI, and ICT, reflecting the integration approach required in smart building design. So it's not only architecture, but varied other fields that will incorporate, and we will see in this FDP, how the other allied disciplines helps us to achieving the zero building concept. I sincerely hope that all participants will find this FDP academically enriching and professionally rewarding. Thank you all for your participation and support. Wishing you a successful and enriching program ahead. Thank you, and best wishes to the participants and the organizers of this FDP program.
Thank you very much, sir. Now I request the Principal Investigator and ICT Academy NIT Patna, Professor Sahana sir, to kindly share his views. Sahana sir.
Actually, camera is not working. On behalf of and ICT Academy, NIT Patna, I would like to welcome all the participants of today's FDP, all the research scholars, all the coordinators of online FDP. First, I would like to brief about and ICT Academy. Electronics and ICT Academy, NIT Patna, is an initiative taken by Ministry of Electronics and ICT, supported by Ministry of Electronics and ICT, Electronics Information Technology. Our motto is to develop your trained manpower and organize faculty development programs in the area of electronics and ICT domain, right from quantum technology to blockchain, AI, ML, and all. We touch all recent technologies like in manufacturing domain, 3D printing, as per requirement of the industry. And all the courses are based on your industry requirement and in line with the industry. Here in this online FDP smart buildings, coordinators had designed this FDP in quite balanced way. There's a proper balance between theory and theoretical and hands-on sessions. Now, if you look into our track record, last 6 years, Electronics and ICT Academy has trained more than 25,000 faculty members and students in the area of Electronics and ICT Academy. And in the same, we are moving forward to train more manpower in the area with a big goal. And we need your support, further support for this. And we are getting a lot of support of all the faculty members throughout different colleges of our country. Like we have collaborated with different IITs, NITs, and different your central universities to conduct your faculty development program through online, offline, and hybrid mode. Here, our director, Professor P.K. Jain, and Chief Investigator of Electronics and ICT Academy, Professor M.P. Singh, sir, giving lot of support and effort to move this academy forward. Further about the program, as per ministry mandate, all the participants should attend assessment process of the FDP after completion of this FDP. It is basically MCQ test. And in addition, at least 70% session of this FDP should be attended. Then only academy can issue the certificates. So that's why my request to all the participants is to follow this norm such that we can issue the certificate to the successful candidates. And I would like to thank the organizer, coordinators of this online FDP for designing such a your online program to train the participants. And I would like to thank for their initiative. With this, I would like to conclude. Thank you. Thanks a lot.
Thank you so much, Sahana sir. And thank you so much for our briefing about the EICT Academy of NIT Patna to the participants, and also throw some light on the according to criteria about the certificates. So thank you so much. Following that, I invite the coordinator of the program, Architect Swaroop Meena, Assistant Professor of Department of Mechanical Architect and Planning, to brief about the participants registered in the FTK.
Good morning, all of you. Respected Director Sir, P.K. Jain Sir, respected Head of the Department, Professor Fulana Rajak Sir, from EICT Academy, Professor Sahana Sir, and the convener of the FDP, Professor B.K. Das Sir, and all the dignitaries. I welcome you all. I will take a very short brief about the participants. We have received almost 75 responses for the participation, and we have very good, spread out among the states, and and we have 56 participants that are male and almost 44 participants that are female. So that's a very good mix. And other than that, we have received applications from 19 states of India, in which 74% are faculty members, 12% are PhD holders, and we got almost 7% from industry and remains from masters and bachelor's program. And all these participants are from India also, and we have also got some of the participants out of the India also.
Thank you, Meena sir. Now I will request you to our brief about our today's session experts, senior scientist Meena sir. So please brief about the participant, about our session experts.
I welcome Dr. Chandra Swaroop Meena, He is a senior scientist. Dr. Chandan Swaroop Meena at present is working as a senior scientist in architecture, planning and energy efficiency design of CSIR, that is Central Building Research Institute, Roorkee. And he is also holding an honorary post of assistant professor in Academy of Scientific and Innovative Research. Dr. Chandan is working in the field of mechanical engineering with a specialization in building energy efficiency, heat transfer, renewable energy, solar energy, two-phase flow, computational fluid dynamics, thermal comfort, and indoor air quality, solar air conditioning using descent wheel and heat pump, water heating system. I welcome you, Dr. Chandra Swaroop Meena, and we are very thankful to him for taking our uh, as a keynote speaker. Welcome you, sir.
Thank you, Subham sir, to brief about the today's session experts, senior scientist Meena sir. Sir, we are extremely grateful for your time, and we are confident that your talk today will be immensely enriched and beneficial to all the participants. So, with great respect, I invite you to kindly deliver his talk. Meena sir, please start your session.
Thank you. Organizing committee chairman and other members of the organizing committee and respected head of department as well as the director NIT Patna. Thanks for introducing me to the participant. So shall I start sharing my presentation?
Yeah, yes, sir. Sure.
I hope my slides are visible to all of you.
Yes, sir. Yes, sir. It's visible.
Thank you. Before starting this like introductory kind of lectures about the renewable energy utilization to improve energy efficiency in buildings, or I must say there are two topics I'm going to cover in this: the renewable energy potential to improve the building energy efficiency, or one can say to achieve the net zero energy buildings. Another is to fundamental of renewable energy utilization to improve building energy efficiency. These are the sequence of my presentation. Before like start or before to implement any solution in the field, so we must know the fundamentals of any subject, so that the proper or scientific interventions with through the scientific intervention, the solution will be implemented and that can be used for societal benefits. So this is the sequence of my presentation in which I'm going to cover the motivation and the background of the study and the what challenges we have faced and the which kind of methodology we have to adopt to improve our design and other aspects and research application and needs. Let's start with the motivation. As you all know, this SDG goals, there are 17 SDG goals in which our organization, that is CSIR, Council of Scientific and Industrial Research, under which this organization Central Building Research Institutes counts. We are working in the Ministry of Science and Technology. So our target, because we have set goals and the mission and visions of individual labs. So our lab target is to do the research on the building aspects, from safe construction to safe demolition. Entire aspect we are covering. So there is a different department. I am from energy efficiency department. So we are working mostly heat transfer through buildings, how we can improve the societal or like social life of the people, those who are staying in the harsh weather climate like Leh Ladakh, where the that is known as the cold desert, as well as in Rajasthan, that is hot desert. So these are the few SDG goals we are working in this area, that is SDG 7.
SDC 9, SDC 11, and SDC 13. Affordable and clean energy utilization. By utilizing the affordable and clean energy, so we can holistically work toward the improvement of our nation. And another is industry innovation and infrastructure. And 11th is sustainable cities and communities. Another one is climate change. So climate change is the holistic approach, or we are facing nowadays. The temperature is continuously increasing year by year. So climate law.
Excuse me, sir.
Yes.
Your like slides are not changing.
I am in motivation slide. Is it visible?
No, sir. This is starting slide only.
The first slide, sir, we are seeing. Title slide is.
Okay. Let me again share. I think there is a problem in.
It's working, sir. But, sir, make it full screen.
Okay. I have already shared and make it full screen, but I don't know. Okay, let me again. Is it visible now?
Sir, it is visible.
Or slides are changing, sir?
Sir, you are right now in third slides. We are seeing third slide.
There's motivation.
Yes, sir.
Part.
So make it your PPT full screen, sir. In
It is already in full screen. Let me again share the entire window. I think there is a problem in.
Okay, no issue, sir.
Okay, now I hope everything is visible. Our slides are also changing. Is it okay now?
Yes, sir, it's fine now.
Okay. So I was discussing about the motivation, in which area we are working. So everyone knows as the population is growing fast. So the challenges are also in meeting the energy efficiency as well as in the thermal performance of the buildings, and how we should design our buildings in such a way so that it can reduce the heat load of the building as well as the cooling load based on the climatic conditions or climatic zones. So these are the basic outlines where we are going to if we are trying to make changes in the societal benefits or in society, so that will be great initiative. So these are the goals based on which we are working, that is environment, because environment, energy and economy, three are the aspects which are usually dominating the societal need. That is environment, we have to take care of the environment as well as the less energy consumption. Whatever appliances we are using, that should be energy efficient, utilizing, if they are eligible for utilizing the renewable energy as much as, then that is also the one step towards the energy efficiency. Another is the economy. One can say directly before using any system, okay, whether it is affordable. The few terms are very quickly comes in our mind before buying or before going to adopt any kind of technology. That is energy efficiency, environment friendly. One can see, okay, in a individual manner, one can see, okay, just leave it environment, because environment is government duty, they will take care. Or point is that should be affordable and energy efficiency. Energy efficiency and economy are the individual's concern, and the environment, so-called people think, but we should not think like that. We should also consider this environment aspect also, so that it can be holistically design the building, because at the starting of any construction or any building typology design, there is a problem to not cohesively work in the nation's development. Like architecture will design their separate building, then comes to there is a number of civil engineer, they will design as per their codes, IS code and other things like energy, net zero. They will not take care about the energy aspect and environment aspect. So during the initial stage, we should focus on the environment, energy, and economy aspect of the buildings. These are some backgrounds that are already reported or it is available in the public domain. These are some facts and figures. You can see now what is the status of our country or as a world as a whole, where we are lying, and if we are doing consuming or we are growing like that, so what will be the future consequences of this? So as we are taking about the building sector, we can clearly see that building sector has a great global warming potential and cause carbon emission through almost 40% of energy consumption. That itself is a great percentage. So one can see here temperature anomaly since 1850 took 1-2 decade before. So it has already a temperature change pattern one can see in this graph. So it is continuously increasing. So this is available in the public domain. And the other thing is through this pictorial presentation, we can see that the emission through building sector is also increasing, or embodied emission one can say caused during the manufacturing and application of construction materials. And the second one is operational emission caused by the energy consumption for building operation. So this is the basic background. One can see, okay, we are working in the area of CO2 capture, CO2 CCUS, carbon capture sequestration or utilization. So this is already we have crossed the 400 in the year 2021 itself. So now we are living in such an environment that is not good for human health, as well as we are not much concerned about these are the problems. So this is the another facts and figures, the population growth and population growth percentage from 1955 to 2020. You can see in this graph. So the growth percentage, okay, we are in the good state, but continuously at the same time, the population growth is also increasing. So, and the global energy consumption pattern, that is definitely cause of the carbon emission from various sectors. So one can see in this pattern, that is the consumption pattern of different building sector and industry sector. So one can see industry and buildings are the major contributors of energy consumption. And at the same time, because once we are using the energy consumption, or we are we are making buildings that is energy intensive. So at the same time, emission also contributing in the same manner, 31 to 39% of industry and building sectors. So these are the some figures. All these we can see the reduction strategies lead to reduced energy load to the building that it fulfilled through the renewable energy system lead to net zero energy buildings. So now the picture of renewable energy, because without moving towards the renewable energy, we cannot even think about the holistically the net zero energy buildings. So the problem is in the house and in the building, or one can say in the industry. So we are taking the domestic household. So one can see the different percentage of 25% of wood consumption, 39% of CO2 emission from the one house, 30% of waste generation. Out of total entire other sectors, if we include other sectors also, the buildings holistically, whether it is domestic as well as the commercial spaces, these are the energy or other things they are using. These are the tentative ratio of the building CO2 emission and the energy uses. One can see here, these appliances are using maximum energy, or one can see the air conditioning. Air conditioning also using 60 to 40% of the total energy consumption. One can let's take one example. In house, we have TV, we have fans, tube lights, and AC, fridge, and other washing machine, mixers, and other things. So the major contributor of the energy or like major energy consuming device is air conditioning. Air conditioning, one can understand like in Rajasthan, air conditioning is cooling the air, and in Ladakh, air conditioning is heating the air. So in more or less in both the cases, the energy consumption pattern is maximum in the air conditioning. So why air conditioning are consuming this much amount of energy? What is the root cause of this thing? So why we call like at the initial stage, we should design our building such a way so that the thermal comfort in the building should be maintained. So there is a two approach. One is passive and another is active approach. So by utilizing only passive approach, one can reduce, if efficiently designed, then up to 30 to 40% excess energy utilization can be reduced by the passive architecture or passive strategies. But that only applicable at the initial stage. So these are the something that one can one should know. Or I think that this is general facts to being a architect or energy energy efficiency related aspect. These are the some facts and figures. This is energy consumption pattern. I have already discussed the residential, commercial, transport, and industry. So this residential, commercial, and industry comes under building sector. Building sector, buildings. We are using for domestic, for domestic purpose that we known as residential, commercial, and industry. But more or less, one can see from the peak that is because of air conditioning. Air conditioning, that is approximately 59%. So that data somewhere is reported around 40. In some literatures, it is given in the range of 40 to 60. And other things one can see: lighting only 12%, refrigeration 8%, washing machine, electronics items, and other cooking and other appliances. So one can see these are the minor thing, because we are intensively using to make our space comfortable. We are using air conditioners, and in this sector also, in commercial building also, refrigeration, water heating for utilizing the in the industrial application. But at the same time, this figure also reaches to 40 to 60% if we are talking about Leh Ladakh, because where the water heating and space heating is the major contributor. One can see HVAC. This is nothing but also air conditioning. One can see 44%, because I have already discussed the 40 to 60% energy being consumed by the air conditioning. And one can see cooking, other uses, and office equipment. They are minor, 5%, 14%, like that. But there is, I'm not saying that this is the saturated or energy efficient appliances are available. Still, there is a huge scope to work in this area to further reduce the cooking energy as well as water heating energy and lighting. From previous studies, so still we have in the good position to utilize the efficiently or energy related thing. So one can usually nowadays we are listening this global warming potential and CO2 capture, CO2 utilization, CO2 sequestration, and like that. So how this entire global warming potential CO2 is influencing our building sector, industrial sector, transport, and other activities, how they are contributing. So one can see, being an architect or being a HVAC engineer, so there is two terms usually comes in the mind, that is embodied emission and another is operational emission. The embodied emission, that is material manufacturing during the manufacturing of the material, other applications, because final product, whatever we are seeing in our site or in the construction site, I must say, So how they are emitting the CO2, or how they are contributing to global warming potentials. So these are the methods of reduction. How then at the initial stage, sustainable material. This term sustainable, usually everyone is using sustainable. How this is sustainable? So that kind of material that has less embodied emission during the manufacturing as well as the transportation, and the final product, whatever we are using, that should be less less contributed in the terms of CO2. So less, it's mean if some material is using X, so the sustainable should be X minus delta X. At least significant, like something should be reduced as compared to the available, conventionally available material. High insulating eco-friendly materials, AAC block, VC, plastic, C&D based bricks, so that the embodied emission, contribution of embodied emission can be slightly reduced. This is an important thing, the operational emission, the utilizing different appliances, lighting, water heating, appliances like solar water heating. One can move towards solar water heating system in Leh. But the challenge is, if the temperature is minus 10 degree, sorry. I hope it is visible.
Yes, sir.
Okay. Sorry. Let's start with the appliances. So energy efficient appliances. There is like 5-star rating, 3-star rating. So what is the difference between this kind of star rating? This is directly related to the energy consumption. Suppose it is consuming 1000 unit per year, so it may be consuming 1200 or like more units of electricity in a year. So this is the different topic. I'm not going into this. And another thing is space conditioning, space heating as well as space cooling. So cut short, we can see the AC. Solar passive design, building physics, geothermal exchange, thermal insulation, other also, not only geothermal, solar, as per the availability as well as in the site specific renewable energy potential. So finally, it is reducing the energy consumption load in the building. So in particular, this kind of building, the AC will not be using the 40 to 60% of electricity or power. It might be using 20 to 30, but it is also a significant. So further continuous, if research is going on in this area, then this figure will also maybe talk to some like acceptable figures. So this is the like global warming potential of CO2, how they are other things, the operational emission, embodied emissions are contributed. Let's come to the fundamentals of net zero energy consumption building, net zero energy building, net zero energy, net zero emission buildings. So these are the different terminology, but contributing towards the energy efficiency or NZEB, net zero energy buildings. This somewhere in literature you can find the net zero energy building. Somewhere you will find net zero emission building. So this is more or less if we are able to reduce the CO2 and the energy. So these both are like contributing or like helping each other. So the other terminology is like somewhere we have found out in any reports or in journals, it is written as net zero energy building. But at the end, all things are same. How now it's a this is are not different meanings or different approaches. The total or the like other things are net zero energy consumption, zero carbon emission. These are the two different aspects that we have to take care. So how to achieve zero energy consumption building? What do you mean by zero energy consumption building? If here is the energy, there is the emission or renewable potential. One can see the renewable energy. So one can see I am producing this much of amount of energy through renewable, but I am at the same time I am also utilizing this much of amount. And another person will say, okay, this is my graph. I am producing energy from renewable energy sources this much and also consuming this much. So this is also known as net zero energy building. This is also known as net zero energy building. But we have to think toward to drop this peak to the minimum. So why we need this much of amount of energy in any building? Okay, based on the bare minimum way we will design any building. Okay, this is properly designed. This like materials what we have used in the construction in the building, that is energy efficient, sustainable, affordable. Then why this much of amount of energy is required? So why should not this much of energy required and this much of like energy consumption? So this because any building that are using X amount of energy and that same building is producing X amount of energy, then that building generally so called we can call as net zero energy building. But this approach in by seeing the climate change and other things, we have to reduce the energy consumption. At the same time, we will go with the high energy production through renewable energy. Then only we can able to reduce the CO2. So this is the different aspect one should take care before designing any building, whether it is architect, whether it is civil engineer, whether it is HVAC engineers, like that. So this is the different thing. There is a step. One can see there is a different step how one can achieve the net zero energy building. So there is a two basic steps I'm discussing in this particular slide. That is energy efficiency. So efficient building construction, efficient system and appliances, operational and maintenance, change in user behavior. And another thing is addressing remaining energy needs. Whatever we have addressed, the remaining part we will be take care from the renewable energy sources. So we have to think in such a way so that bare minimum energy is needed for making any kind of spaces or building spaces in this to make this energy efficient. This is the basic mechanism, or one can say the holistic or hybrid approach, so that one can make their own house or building as a energy efficient or net zero energy. So there is a two term. One is net zero energy building. Another is energy efficient building. So first we have to achieve this energy efficiency. Then we will go for net zero energy building. So how we can achieve this energy efficiency in building? Initially, we would apply the building physics. What is the fundamentals of buildings? Load optimization. How much building is utilizing or how much building is consuming? That may be the appliances, equipment, and other things. By utilizing the star-rated or energy efficient appliances. So that may lead to improving energy efficiency, energy efficient system, or energy balance. Energy balance of this renewable energy as well as the bidirectional meter. Or there is so many approaches are appliances are coming in the market. They are giving the live data as well as the live performance of the building, how this building is producing, how it is taking from grid, how it is giving to the grid, and the entire data management also the devices are doing. So this is the final or holistic approach one can say the user target. User का target होगा कि energy efficient building बनाना. Another stage is energy optimization. Whatever appliances or things are being used in the house, that should be energy efficient. And at the last, integration of that much amount of clean energy resources. That may be solar, that may be wind, that may be geothermal, biomass, as per the availability as well as the site. One can see, okay, geothermal potential. Geothermal not for electricity generation, geothermal for space condition, wind, solar, and biomass, like that. Or this user target to building energy optimization, reduce energy demand, renewable energy source, performance indicators. These are the performance indicators. This is the energy balance, how we should balance the energy, and active design strategies. And these are passive. This should be considered at first. And other thing, energy balance 2 and 3. Based on that, we should go for renewable energy. There is different simulation tools, like it is depicted in this thing. This is open source. This is license based. So I am showing one simulation based on the design builder software. This is just a case study, not in depth. I have not shown in this slides. So this is assessing building energy efficiency. So how the energy plus based, this is also energy based plus design builder modeling simulation software. The energy assessing tool enabling the user to work with virtual building model. Complex design are made easy with the help of predefined templates. So whatever like latest version, it is having predefined templates, so that there is no much time there is no need of to invest the much time on this. And predefined building materials, it is available each to provide a range of environmental performance data, like what is our target: energy consumption, carbon emission, comfort condition, HVAC component, maximum summertime temperature, or daylight luminance. So this is the basic data we have to collect from the by visiting or pre-need assessment visit. So what is the need actually, and how we can predefine design geometry, predefine construction material, heating and cooling design calculation, like that. So this is the study for campus only. We have like this is latitude, longitude, elevation of sea or climate, or average annual temperature, Köppen classification, and actual climate zone. So this is the like location we initiated for this case study. Okay, this particular building, if we are taking for improving the energy as well as the thermal comfort, so then what will be the approach? Or there is a permutation combination. Okay, we will we will add this material in this wall, in this roof, in this floor area, like that. Or what is the orientation of building, how this building will behave after modifying. So before going for actual changes in the site, then what will be the approach? How like if one will ask civil engineers, okay, which kind of insulation will you use? There is a different thermal conductivity, defined thermal conductivity, U value of U value of any sandwich panels. In CBRI itself, we are having this thermal conductivity testing facility. So different organizations or industries are approaching day-to-day basis for evaluating or for get the certificate of the thermal conductivity as well as the U value of any building components. That may be wall, that may be roof. That also we are going to establish in a few months. Another is fire safety. There is a different safety parameters, different other parameters that we take before designing any building or retrofit, repair and retrofit. So first thing is site selection. So in that site comes in the cold climate, warm and humid, hot and dry, and temperate and composite. So if we consider composite or Roorkee as a site, then that comes under composite climate. So this is composite climate. Model preparation, basic design models. Okay, this will be the existing model. If we are going for the repair and retro. Parametric properties, which kind of parameters will be affecting. Then we will go for simulation. Sometimes it will directly give the good combination or tune the results with the existing one. Sometimes we have to modify it or we have to try and to improve the error. This is the iteration in different properties. Simulation result analysis. How one should know how the simulation result analysis part will be done, because this is the critical part. The interpretation is also very important. What kind of interpretation we are doing, we are seeing in this simulation and the actual. So we have to validate our model with the at least one any predefined study to result comparison, and then only best outcome and improve energy efficiency will be done. This is the methodology part, how we can go. This is the actual site. This is the one water that was not being used in few years. Like that, so we will select we went to see whether the site is suitable. So we have prepared this model description. This was the domestic kitchen and the common circulation area, domestic bedroom, domestic bathroom, domestic toilet, and lounge. Other thing we have placed and we have created the model with the existing material. What kind of material is being used and design model in the design builder. What is the orientation, how this facade and other things are placed, and we have played this because this water is placed together, like in line there are so many waters. So, we have designed based on the color combination and actual thing, the floor is with this tiles are placed in this floor, roof, wall, and other thing. So this is case is very simple as that, like how we can improve the existing brickwork, cement plaster with thickness of 220, cement plaster 13 mm, thermal conductivity in the range of 0.8 to 0.35, density like that, a U value, partition wall, similarly flat roof, ground floor, glazing, windows frame, and extra. One can see by taking the reading. So this is the actual reading, and we have tried to duplicate. Okay, this is this much of cement plaster being placed, brickwork, cement plaster partition work, and at the same time flat roof. This is the ground floor. Ground floor is ceramic glazed floor, and the cast concrete and glazing also 6 mm single glass. Window frame, external door. So this was the simplest model. These are the material property visualization case study. We also try to replicate the similar pattern in the simulation so that one can understand easily. External wall, double leaf, external wall, single leaf, single RCC platform, simple flooring, wooden door. So this was the rendered output of the case. Southeast view with sun path, southwest view, southwest view with the with or without this thing, sun path. This is sun path diagram created. This is the conventional model. We modified with the few details. So this is the case study. After the second modification. So this was the second this table. Second table is showing the conventional building model, and here highlighted the parametric properties that are different in case 2 model from the previous model. So this is the simplest model case 2. Material visualization already I have already discussed, shown in here are changed components with external wall of simple brickwork plaster, both face with cement sand plaster. The roof is changed to the reinforced concrete slab with cement plaster on inner face and layer of bitumen mud puska, concrete tiles, cement plaster on external face. The ground floor has an extra layer of brick slip and clay underfloor and stone marble laid in the topmost layer. So, and the window glazing in this model has changed to the double glaze with 6 mm clear glass with an air gap of 30. So, why we have put this air gap? Because air is the air will work as a insulating material. So previously, architects used to construct this red truck bond in which approximately 20 to 30% material saving also take place. So like that, this is the case too. We can see in the rendered images, the external wall, double leaf, conventional flooring, conventional roof. Further, this was the rendered model of case 2, how it was improved. This is the case 3. So case 3, these are the table that in case 3, an additional layer of expanded polystyrene is added on the wall, outer face, to provide insulation and reduce thermal transference. So for this particular reason, we added the expanded polystyrene, and in roof section, a layer of insulation with lower thermal transmittance is added to induce the heat effect through the roof system. How we can improve the thermal comfort inside this building. So this was a rendered again building component. So this is the building component. One can see the insulation external wall, double insulated external wall, single leaf, flooring, how we have changed. So this is the different rendered building cases. You can see in this how we have step by step improved and checked the feasibility. So the result analysis, the main thing I have already discussed in the previous slide, the interpretation and result analysis is the important part, so that we can get the efficient or good results. Or what is our purpose? In this, our main purpose was to CO2 emission reduction as well as the energy optimization. So this was the main target. So this is the case 3. This is the rendered image of case 3, how we have changed insulation and other things. So in rendered image, one can see there is a difference between the color and other flooring pattern and other things. At the end, we further improve we added the brickwork with insulation inside it also. So to check whether it will work or not. So this is the rendered building component case 4. So this is rendered building images case 4. This is case 5. How we have let me explain this case 4 part. In this case 4, the insulation is provided at the inner face of the wall to analyze the change in the thermal behavior of the wall changing. The placing of insulation layer. So in roof section, the topmost layer is changed here to concrete tile. And in this model, the window glazing has been changed to double glazing with 6 mm glass on exterior face and 6 mm clear panel. So like that, the low emissivity effect due to this glass that minimize the amount of infrared and ultraviolet light that comes through the glass without minimizing the amount of light that enters the. So like that, we change in this case 4. Further, we also analyze through simulation, that is case 5. In case 5, the brickwork is changed to A. And with no insulation layer, it has to see the effect of reduced thermal transfer AC block used in building and insulation layer of EPS. Like that, the floor and the low, like that added in the floor and low to lower the heat transfer from ground. So, and the glazing has been changed to triple glazing, 3 mm clear glass with 6 mm ERV. What is the effect of glaze? So, this is the different things we have tried. Case 5. This is the rendered image of case 5. And like that, case 6 also, external wall and external wall B. This is a rendered image. So, in this, what we have changed, only modified parameters is added in the EPS insulation layer to the block work on the wall outer face with this lightweight cement plaster on the outer face and gypsum plaster on the inner face. So one can see the color also change based on we have predefined parameters in this. So this is the like final result analysis. How modification is contributed. So one can see in this graph. Here is a this annual electricity U value. How this U value is affecting with the external wall with different thickness, partition wall, roof, window glazing. So the U value overall heat transfer coefficient because U value of any building component is contributing significant in designing any system. This is monthly electricity. Here we have plotted this monthly energy consumption trend to all 6 models. So this one can see this is model 1, this is 2, 3, 4, 5, 6. So the different color is showing different models. So the peak that most of the energy consumption take place in the summer and winter season is least consumed during the transition period between summer and winter. The highest peak between November and January, you can see November and January. November, December, this is the peak. So this peak between November and February depicts the high need for heating in winter and the cooling need in the summer season. Comparing all 6 models, it can analyze that the model 1 is the highest energy consuming building all around the year, and the effect of lower thermal transference material use can be seen clearly in the energy consumption in model 6. It's the least throughout the year. So one can see definitely this energy consumption pattern of this model 6 is consuming less energy. So similarly, we have also analyzed the different parameters, like what is the effect of carbon emission comparison for under study building model. So what will be the other things that are affecting buildings. So now based on the building energy demand, the annual carbon emission is calculated for all 6 models and plotted in this graph. It can be seen that most the energy efficient model has the least carbon emission production. So this is not a claim that this is not a claim that this is the efficient. There is still scope to minimize this annual CO2 production by the scientific intervention. So still we need to minimize as low as the latest sustainable building materials are coming. So it can be seen that most energy efficient model has the least carbon emission product, but the model 6 is producing around 49% less carbon as compared to the model 1. So by comparing these two, so this is just a almost 50% reduction in the CO2 emission. At the same time, 0.6 0.06 kg of CO2 per kilowatt hour electricity is being consumed in this. So this is the thing we need to think about before designing any system. So this is an annual electricity consumption. One can see the existing model annual and the after repair and retrofit. This energy annual electricity consumption also will be greatly dropped down to the 1380, which is also more than 50%. So why we are not going for this kind of study or scientific interventions before designing? We are usually going with the glass. In Rajasthan, placement of glass is, I don't think so, is energy efficient, because the glass has the thermal property or like the property that only allow the short wavelength, and it will like work as a barrier. It will not allow to go out the long wavelength. So as the wavelength and temperature is inversely proportional. Short wavelength is having high temperature, long wavelength is having low temperature. So one can feel in the car during peak summers, they will leave the car in the open space in the daytime around 2 or 3. Then after even we have traveled like 100 kilometers with full AC, in a minute or so, it will be like much more hotter than as compared to the outside. So this is the clear example of short glass property. So because of that glass, short wavelengths penetrate in the car space, and it will absorb with the seat, dashboard, and other things placed in the car, and it will convert from short wavelength to long wavelength, and it will because glass has the same direct property, it will only allow the short wavelength. So this is the different approaches how one can design, or one should design in such a manner so that the overall global warming potential and CO2 by seeing the environment as well, not the only affordability. Because if we are able to make a building in such a manner so that it will be environment friendly as well as energy efficient and affordable, then the overall goal will be achieved. This is the main issue. So that this is the annual heating and cooling load comparison for all annual heat.
कोऑर्डिनेटर तो आएगा तो दोनों किसने दिया ने क्या किया, बट सी माय ओनली पॉइंट वाज प्रीवियस वन वो निकालना अपना टैक्सोनॉमी। अरे creating value, analyzing, applying, understanding, remembering, critical analysis है, understanding है, ये है।
Hello, am I audible?
Yes sir, you are audible sir.
इसकी लैंग्वेज को ही ट्वीक कर रहे हैं ना।
Hello Kriti ma'am,
ये वर्ड्स
please ma'am mute yourself.
अकॉर्डिंग सो इनको बोलो तो ये कर देते हैं।
Hello,
ग्रेडिंग क्राइटेरिया वाला।
I think someone has unmuted. Hello,
तो मैं सिलेबस क्या हैंड बहुत सारे सब्जेक्ट्स में ऑलरेडी है जहाँ पे नहीं, बट अगर ओवर जैसे पिया का 5 ईयर कोर्स है तो 5 ईयर में सम और द अदर प्लेस दीस वर्ड्स आर shaping up anywhere this must be okay. अगर हर कोर्स में सारे के सारे पैरामीटर्स चाहिए तो वो आई डोंट थिंक वो रिक्वायर्ड है। तो फिर इसमें तो है वी हैव टू जस्ट गो थ्रू एंड सी कि ऐसा कोई पैरामीटर है ब्लूम टैक्सोनॉमी तो कहीं पे भी नहीं है, वो बस उतना ही ऐड करें।
hello,
There you need to change the whole.
No, Miss Kriti Mishra, please mute yourself.
And similarly for CO2.
I think
Don't change it because CP पहला task is उसको break कैसे करना in the 4 years.
हेलो हेलो हाँ नहीं अभी नहीं हुआ है. I hope is it visible?
Yeah, yes, it's visible, sir.
Okay. So should I restart from the slide or previous?
No, sir, you start, sir. This one.
This is annual heating and cooling load comparison for all 6 models in terms of heating and cooling demand for hot water heating. The DSW represents the domestic hot water and heating, cooling, and domestic hot water. So one can see the major contributor in the composite climate and in warm and humid or hot and dry climate, cooling is dominating, and as well as in cold climate, the heating is dominating. But maybe slight number in like slight changes in number maybe occur, but the pattern will be more or less similar. So this is the annual heating and cooling load comparison for all 6 models, in which clearly model 6 with the slight modification, we will apply 1 layer of insulation on the roof, so reflective tiles and the insulations and the change of glasses. Then the heating load significantly reduced from cooling load significantly reduced from 900 to 155. So this is the like fundamentals, or one can, by doing this trial and error methods, they can improve the performance as well as the energy efficiency of the buildings. So this is now the renewable energy Roorkee, how from further, if we want to reduce from 155 kilowatt hour annually to further, if you drop down, then what approach should be? That is renewable energy. So the renewable energy that comes from the source which are continuous replacement, such as the solar, geothermal, wind, hydro, etc., etc. So there is the utilization of hybrid or renewable energy resources will be based on the location and the renewable energy potential in that particular location. So this is the basics fundamentals. How we can integrate. This is the architectural point of view, and now HVAC or mechanical part will come into the picture, and the hybridization of this kind of system will improve further the energy efficiency toward the net zero energy. So without renewable energy and only architectural point of view, only civil or only HVAC efficiency will not be able to take us from normal building to conventional building to net zero. So this is some basics. So this is water heating thing that I hope I'll discuss in the next lecture. So this is the thing. Or one okay, let's discuss the fundamentals so that the further in next lecture we will discuss about the other. So this is the market survey. The type of this is particularly for Leh Ladakh, not for any other climatic zone of India. So we are working towards to meet or to give a building solution for Leh Ladakh itself. So there the water heating, one can see the market rate of unit water heating products. So we worked from last few years to reduce the energy as well as price and improve the energy efficiency. So this is the modified system we have prepared. It's an assisted heat pump water heating system. Heat pump is a mechanical device that we integrated with the renewable energy source. So this is the working principle. You can see the main thing is the system that we have designed will work in the, if the solar radiation comes in the range of 3.5 to 4.5 kilowatt hour per meter square per day. This is the NREL data. So our system will work very fine if the solar radiation is up to 3.5 or 4 kilowatt hour per meter square. So this is the mathematical model. How we have pressure drop is negligible in evaporator condenser, because in real performance as well as in mathematical modeling there is a gap in the final results. So because we use ideal condition assumptions, okay, pressure drop is negligible in evaporator, but this is not the actual case in the field. So we have faced different challenges. So this is the efficiency of network collector, how one can calculate. This is the efficiency. So this is Q, useful energy, area of collector, and solar incident on the flat plate collector. Thermal performance of the flat plate collector, Q useful, and this is the equation in which average is the collector efficiency factor, area of collector, transmissivity, absorptivity, and this is the solar incident, overall heat transfer coefficient, T evaporator minus T ambient. Like that, overall heat loss coefficient also calculated by summing the top heat loss, bottom heat loss, and top heat loss coefficient can be calculated with this formula. These are the different equations that I am not going to discuss in detail. So this is in simple COP, that is the thermal energy rejected by the condenser. This is very basic. This is like a bachelor's or master's degree course. But these are the different component of the setup. This is the positioning of measuring device instruments. So how we have set up and modified this system. We have tested in our lab, one guest house that is entirely bamboo structure. This is and to make this like visibly good, we have painted the exterior walls. One can see here. This is entirely bamboo structure, column and other things also. The entire building is we have made from bamboo. So in that renewable energy. Utilize where we have utilized the renewable energy. So in maybe hopefully in next lecture I will discussing the renewable energy potential in buildings. Thank you. Shubhamji, if anyone has any question or suggestions, please post or.
Arpita?
Yes, sir.
We can continue with the question.
Yes, sir.
Apart from this, CBRI, particularly this department is working in different aspects. Like currently we are working in one project that is HARI, High Altitude Region of India, in which we are dealing with providing the energy efficient solutions to the high altitude of India, like Leh Ladakh, Northeast, Uttarakhand, Upper Himachal. Recently, we we developed one setup called Kalpa-Kinnaur district and Leh Ladakh ITP. It is also in next presentation I am discussing that. Yes, please.
So the map you have shared by NREL, in that people used to say in Bangalore there is a very less sun radiation, so we can't go for solar radiation. But when I referred the map you shared by NREL, it is shown like it is positive zone in positive zone.
Yeah, that is positive zone. Like one cannot say directly that is the positive zone. The setup or the system you have designed that should work in that particular solar radiation pattern. that 3.5 kilowatt hour per meter square per day, one can see in general perception what is the thinking of common people. In Leh Ladakh there is a cold, but solar radiation pattern, that the short wavelength that is coming on the solar Leh Ladakh or Kalpa or Kinnaur, that is very much high as compared to the Shimla. So the utilization of efficient short wavelength, that is the challenging. Conventional solar systems, they are designed in such a way they can only harvest more than 5.5 kilowatt hour per meter square per day solar radiation pattern. So we have to design our system such a way so that it can harvest 3.5 to 4.5 like that kilowatt hour per meter square per day solar radiation pattern. This is the scientific intervention.
Okay, sir.
Any other participants, if they have any query or question, please ask the experts.
Chandan sir, this question is not related with the presentation, but since you are from CBRI Roorkee, is it possible for the students to do some sort of summer internship in your institute or some short-term program if it organizes on thermal comfort and like so? And also mostly the architects, they want to do some sort of short program or internship type. Sir, you are muted.
Chandra sir, please mute yourself.
Hi,
Unmute.
yes. Sir, we have dedicated department that is outreach and dissemination services. I am also part of that group also, that department also. So we are continuously inviting applications for vocational training, summer training, and other project related trainings like master's student may come and they complete their master dissertation, as well as BTech or BR students also. Usually architect is full of students. Many architectural universities are sending their students for this kind of.
Okay, thank you, sir. Thanks for the information.
Thank you. If you have any student, those who are interested in completing their dissertation work, as well as in thesis or normal 3-4 months training, then just drop a message and then I will take care.
Okay.
Thank you, sir, for your insightful session. We truly appreciate the way you explain energy consumption in buildings, especially highlighting various applications such as heating, cooling, and the use of star-rated electronic devices. Your talk shed light on achieving net zero energy buildings through a holistic approach to energy optimization and user behavior. Your insights provided valuable clarity on how energy is distributed and utilized across these systems. The case study you shared provides a practical perspective, helping participants understand the real-world implementation and challenges in managing energy efficiently within buildings. Your insights offered valuable clarity on how energy is distributed and utilized across systems. Participants, thank you for your questions and queries. And also, we extend our heartfelt thanks to scientists, Chandra, Swaroop Meena sir, who without hesitation accepted our invitation and delivered the session in such short notice, even though it's his second session of the day. Thank you, sir. And
Thank you so much.
thank you so much. Thank you.
May I leave now, sir?
Yes, sir.
Thank you for having me here. Thank you.
Hello. Yeah, Arpita, just make the announcement to the participants.
Okay, sir. Again for the evening session, like at 4 p.m. Kindly make sure to before the session begins. The updated schedule will be shortly shared in the WhatsApp.
Okay, thank you everyone. So now we close the meeting and we'll meet at the evening session at 4 o'clock. Thank you. Yeah, Arpita, please end the meeting now.
अभी तक मेरे पीसी
हाँ?
मेरा जो पीसी है ना